Hello, this is Mrs. Edwards, and we are going to do the review and preview problems in Chapter 8, numbers 29 through 35 in the CCG book. Question 829 says, find the area and the perimeter of each shape below. Looking at Figure A, I notice that I can draw a line connecting the vertices of my sides, and I can create two triangles. When I find the perimeter of a shape, I add up all the sides. So if I have 5 plus 10 plus 2 plus 11, this equals my perimeter, and the perimeter of my figure is 28 feet. Looking at the area, I want to see how much is the complete inside of my figure. So I know how to find the area of a triangle. It equals 1/2 times the base, which in my top triangle is 5, times the height. And then I need to add my other triangle, which is 1/2 of 2 times 11. So half of 50 is 25. Half of 22 is 11. We're going to add 25 and 11. So the area of our figure is 36 feet squared. Looking at problem B, I know that this side is congruent to these sides, so I know I am working with 20, 20, and 20. I can use my Pythagorean theorem to find the length of my missing side. So 20 squared plus 20 squared equals c squared. So 800 equals c squared. C is equal to 28.28. I know if this side of my square is 20, this piece has to also be 20. So this right here, when we subtract, is approximately 8.28 centimeters. So the perimeter, we're going to add all of our sides. So 20 plus 20 plus 20 plus 20 plus 20, plus that little short piece right here of 8.28 gives us a perimeter of approximately 108.3 centimeters if we round. When we take a look at the area of this figure, I notice that I have a square. The area of a square, I do base times height, so 20 times 20. I need to add the area of my triangle, which is 1/2 base times height. So my area of my figure is 600 centimeters squared. 8-30 says, in the figure below, if PQ equals SR, so PQ equals SR, PR equals SQ, prove that angle P is congruent to angle S. Write your proof in either a 2-column chart or a flow chart. So if we use a 2-column proof, sometimes it's easier not to forget our reasons that go along with our statements. The first statement that we have is the fact that we were told PQ is equal to SR. And when we write our reason, we know that that was given to us. The second thing that we know is that PR is equal to QS, and that also was given to us. We then can say that QR is equal to QR because of the reflexive property, which is also the shared side property. I now notice that I have 3 tick marks around each of my triangles here. So this triangle QRP, is congruent to triangle RQS based on the side congruence theorem. We wanted to prove that angle P is congruent to angle S, and we can now do that because we know that if we have congruent triangles, it implies that we have congruent parts. In this specific case, we're talking about angles. Joey used 10 congruent triangles to create a regular decagon, which is a 10-sided figure. What kind of triangles is he using? Well, he was using isosceles triangles, and we know that it's an isosceles triangle because when we take 360, if we can envision our central angles and divide that by 10, we get our central angles to each be 36 degrees, which means our base angles are larger than 60, so it cannot be an equilateral triangle. Find the 3 angle measures of one of the triangles. So when we think of our 10-sided figure, we take 360 and divide it by 10 to find out that the central angle is 36 degrees. I then know that my base angles have to be the same, so I'm going to take 180 minus 36. 180 minus 36 gives me 144. When I divide 144 by 2, I know that my base angles are 72 degrees each. If the area of each triangle is 14.5 square inches, then what is the area of the regular decagon? So when we look at our area of our triangle, and area equals 1/2 base times height. If our triangle is 14.5 square inches, I know that there is 10 of them, so we have 10 triangles that make up our decagon. So we can take the area of 1, 14.5, multiply that by all 10 triangles. So we get approximately 145 inches squared for the area of our decagon. 8-32, on graph paper, plot A at the point 2, 2, plot B at the point 14, 10. If C is the midpoint of AB, so the midpoint of AB we're going to label as C, and D is the midpoint of AC, and E is the midpoint of CB, find the coordinates of E. So by plotting the points directly in the center, you can see the coordinates of E are 11, 8. What fraction of a distance from A to B is E? When it asks us what fraction of the distance from A to B is E, we can see that it is approximately 3 1/4 of the distance to B. So let's take a look at B again. We want to make sure and draw our slope triangle in from A to E, and then compare that to our slope triangle from A to B, and take a look at those ratios. So our slope triangle from A to B is 14 minus 2 gives us a run of 12, a rise of 8. So when we look at our change of y over our change of x for A to B, we get 8 over 12. When we look at our slope triangle from A to E, we run 11 minus 2 is 9, and we rise from 2 up to 8, so from 2 to 8 is 6. So then when we compare these two, so when we go back to question B, what fraction of the distance from A to B is E? If we put E in the right spot, so E is not in between C and B, so we have letter C, we have letter B, we have letter A, we have letter D. E is in between D and C. So be really careful when you read these problems. So we can visualize the center between D and C, but it asks us what fraction of the distance from A to B is E. So if we look at our line and divide it up into smaller pieces, we can see that we can create 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8, all the way from A to B, and E would be 3/8 away from B. It then asks us to use the ratio from part B to find the coordinates of part E. So if we think back to lesson 7.3.2, we would take 2 plus 3/8 times 12 to give us approximately 6.5 for the x coordinate. We would take our y value, which is also 2, plus 3/8 of our y coordinate, which is about 5. So we can see that our coordinate for point E would be at 6.55. Problem 833, use the geometric relationships in the diagrams below to solve for x. So looking at example A, I am looking at an isosceles triangle because I know the legs are both congruent. I know that all the angles within a triangle equal to 180 degrees. So in order to get the measure of my base angles, I can subtract 82 from 180, which will give me 98 degrees. I then need to divide that 98 by 2, which will give me 49 degrees, which is equal to x, or the base angles of my isosceles triangle. Looking at example B, I also see that my legs are congruent, which means my other base angle would be 71 degrees. So when I add 71 plus 71, I get 142. If I subtract that from 180, I can tell that x is equal to 38 degrees. 8-34, the arc below is called a quarter circle because it is 1/4 of a circle. Question A says, copy region A below onto your paper. If this region is formed using 4 quarter circles, can you find another shape that must have the same area as region A? Justify your conclusion. So if we rearrange these quarter circles into a rectangle, we can move region A. We can take this top half and separate half of the circle here, the other half of the circle here, as shown in the diagram to the right. So we then know that our dimensions are 14 units and 7 units. And we just formed a rectangle from the shape we were originally given. It then asks us to find the area of region A. So by rearranging that into a rectangle, we can easily find the area by multiplying 14 times 7, the base times the height, and getting 98 units squared. 8-35 is a multiple choice question, which is common on the ACT. Which property below can be used to prove that the triangles at right are similar? So looking at our two triangles, we want to make sure and compare similar sides. So if I flip my top triangle over so that my angles are lined up, I can then line up my angles. I know that this side of my triangle is 6, this side is 9. So if I place 6 over 9 and 4 over 6, I know that 6 divided by 9 simplifies to 2/3. 4 over 6 also reduces to 2/3, so they have a similar ratio. So based upon side, angle, side similarity, we can say that these two triangles are similar.